I'm Nathan Shively-Sanders, and let's talk about assignability in TypeScript. Also known as type relations, type compatibility, type checking. It's kind of the most common type check that the compiler does, and so if you're not being precise, it's kind of easy to think of assignability as just checking types at all. Alright, so this is going to be broken into 3 videos. This first one is a short backgrounder about what assignability is. And then we'll move on in another video to structural type checking, sort of an abstract view of how it works. And then finally, we'll look at how TypeScript itself actually works. And we'll actually name function names and so on. So for background, I'd recommend Orta's How the Compiler Compiles video. Basically, a compiler transforms one computer language to another one, and it's divided into phases. We're talking about the checker phase here. We're checking that the program's tree satisfies correctness properties of some kind. And assignability is, like I said, the most common correctness check that we make in the compiler. So there's a number of places it shows up. The 4 most common are here. So we have something like a declaration const x of type string equals 1. The first thing the checker does is check 1, find out that it has type number, and then see that const x has a declared type string, and now we're going to ask, is type A assignable to type B, or is number assignable to string? This shows up also like if you have an uninitialized declaration as soon as you have an assignment, then you're also going to check the assignment in the same way, number assignable to string. If you have a function f that has a parameter that's of type string, then you also check assignability when you call that function. So if you pass 1 in, you're going to end up saying, well, 1 has a type number, is number assignable to string? And then in the other direction, if you have a return statement from the inside of the function and a declared return type, then you're going to type check 1, get number, and then ask, is my return type, is the type of the thing I actually return assignable to my declared return type? So let's look at micro TypeScript. So micro TypeScript is a sort of textbook compiler, sort of the size of one anyway, but it's written more or less the way the smallest possible TypeScript compiler could be. And this is a really simple language. So the only type that's in the language in the compiler for types is just a single field, ID. So this is going to be it's going to be checking assignability nominally, which is not how TypeScript actually does it, but it is very simple. So we've got one type here. Let's look at some of the built-in types. Actually, there's only 3 built-in types. You've got string type, ID string, number type, and error type. And error type is kind of like any, except it only shows up when you refer to a type that doesn't exist. So for example, if you type rx string equal 1, that's one of the statements that this miniature language will check. You could also say things like type y equals number, but that's not really relevant. And you can also have assignments, so you can have x equals 2 or something like that. So the error type happens when you type in some nonsense here that isn't defined. And then it propagates just like any would. All right, so let's see how this little program would actually be checked. So the checker is going to walk the tree, and as it does so, it's going to end up looking at statements, and then one of the statements in this case is var. So the first thing it's going to do is check the initializer, so that's 1 right here. That's going to come back number, and if there's no type declared, then you're done, actually. You can just say, well, return that, because there's nothing to check against. But if you do have something to check against, then that type name gets checked, and then it really is just triple equals at this point, or you ask whether the type of this thing is triple equal to the type of this thing. And so that's kind of the definition of nominality. Obviously, a real compiler with a nominal system would be more complicated, but that's kind of the basic idea. There's also an exemption right here, because if you do happen to say nonsense here, you don't want to get a double error. You only want one error that says, hey, we couldn't resolve nonsense. But you don't want an error that says number is not assignable to nonsense. Well, of course it's not. We don't have any idea what it is. So you skip the error there. Assignment's pretty much the same thing. Yeah, you check the expressions, and then you check with triple equal. So That's the basics of what an assignability check looks like, sort of the most simple possible thing. And nominal type systems are pretty much this simple. I mean, you're basically checking for identity in some way. The only exception is when you have something like subtyping, where you might have class base and class C extends base. Obviously, C is not triple equal to base at this point, but you can also like follow a parent pointer or something to say, well, okay, what about C's parent? Is that equal to base? And if it is, then you're good. And that's not at all how structural type checking will check subtyping.